we're going to get started. So I wanted to welcome everybody to No Limits. And I just remembered Chris Leigh was a speaker many years ago. And what was interesting is what became of that was a lot of excitement and support about what he was doing.
Me?
And because I don't think at the time a lot of people knew who you were, but there were more people afterward that became big fans of what you're doing.
Yeah.
And so we have another interesting opportunity for someone who thinks way beyond what's in front of them, way into the future. And I would normally go through this introduction, but because Jan spent a decade that as part of the Board of Regents and tried to make change, and change is really, really hard everywhere, but it's especially hard there. They specialize in blocking everything that's important. So Jan?
That's not why. I wanted to introduce you, Jason. So I wrote a little stuff for the sake of everybody that doesn't know. Jason has a Ph.D. in computer science from University of Illinois, Chicago. So he was a professor there for a while and remains emeritus at University of Chicago. David Lassner, our current president, maybe he's taking credit where credit's not totally due. He takes credit for recruiting Jason to move to Hawaii about 10 years ago now. Of course, David came from University of Illinois as well. So if you don't know Chris Leigh is moved back to Hawaii. He was a big name producer in Hollywood. Still a big name producer in Hollywood, produced some of the biggest biggest films in Hollywood, actually. And started the Academy for Creative Media here in Hawaii. He's been working closely with Jason, and really, I think between the two of them, they've just been like dynamite.
David put us together. Yeah.
David put
And
us
then before
together.
he started. Yeah.
So
Marvin didn't want him. So David sent him.
it's true. So, so Jason is now a professor in ICS and director of the Lab for Advanced Visualization. I think he's an amazing person who had to build something from nothing. And a lot of people don't quite appreciate or understand what he's done. He's extremely good at getting external funding to build his programs and his facilities. He inspired and nurtured so many students, including our very own Dylan here, over the years. He modernized and I really think broke the mold on how we think about ICS, data, and communication to the world. So he belongs here at No Limits, and I would just pick on three things. One is he broke through the extremely brutal internal politics at the university, at any university, by introducing something new and kind of going against the mold. Number two, he came into a total lack of facilities. In fact, at Keller Hall, which is where Pat used to bring his computer hole punch cards to run on the Wang or whatever machine. Which
I used to use it with all my cards. Back in the day when you wrote code.
I used to teach 360 assembly.
But the problem is Keller Hall still looks like that. So he managed to persevere, get his own funding, build his own programs, build new labs, which are wonderful. And the third thing was in academia, if those of you who don't appreciate, there's extreme silos. It's a huge issue in coming up with innovative, new collaborative ideas. But what I've seen with him is he really broke through that. He has programs on almost all campuses now, and he's an extremely good collaborator. So very unusual person. We're proud to have you here in Hawaii and as part of our community, and we welcome you.
Thank you so much.
Thank you for spending
Thank
time
you.
with us.
Oh crap, now I better make my slides good. Thank you all for inviting me. Jan is really correct. It was really hard starting here at UH. Literally when I landed, the whole lab space wasn't even remotely fit for for like even moving anything in. There was like an air conditioner that had to be vacuumed out every 6 months. Otherwise I get a waterfall, which is not great for a computer lab, right? But the advantage was because it took over a year to get me a lab, that was a chance to just write grant proposals. And so I won a lot of grant proposals. And at the time, I didn't know anybody. And I said, who should I collaborate with? And David said, hey, you should talk to Chris. And we worked on grant proposals together. And then the rest is history. And I'm going to talk to some of that history too. And I hope you enjoy it. It's not super technical because Dylan suggested I try to keep it general for a broad audience. But if you want to ask me technical questions, feel free to do so. I may just show a very blank face because truthfully, at my age, it's really my students like Dylan, right, who graduated that are all the brains now, right? And all I do is do spreadsheets and presentations. So my other roles in the university is I also head up the Hawaii Data Science Institute. And then thirdly, without not included in here is I lead the Change Hawaii EPSCoR program, which is funding from National Science Foundation to bring in a bunch of climate scientists, computer scientists, data scientists, social scientists to help Hawaii figure out how to be more resilient in the face of climate change. These are people who funded me in the past. I thought of a way in the future where I'll size the icon based on how much money I get from them as a way to maybe motivate people. But that's for the future presentation. Today, the title is basically Navigating 30 Years in Evolution of Immersive Analytics. And all that means is I did some fun stuff 30 years ago and up till now, and I just want to talk about them. And that's it. This title was derived by ChatGPT. So I use AI too. So a little bit about LAVA. It was established in 2014. We have roughly 15 to 20 students in our lab at any given time. And they're all funded, either undergraduates, graduates, masters, PhDs. We also sometimes have postdocs. And they're from a variety of disciplines. And the reason for that was because a lot of my influence in forming this lab was what I received when I was at the University of Illinois in this strange little lab called the Electronic Visualization Lab, which was this weird hybrid of artists and computer scientists and folks from other disciplines. And that lab did the computer graphics for the first Star Wars movie in the 1970s. And they went on to invent the first data glove, and then the Cave virtual reality system, which I'll talk about in a moment. So I wanted to bring that DNA here to Hawaii because it was just too much fun in that lab, and I wanted Hawaii to have the same. So when I was growing up, this is it. That's all I cared about, the future and science fiction, and in particular Star Trek. I thought, wouldn't it be great if we could live in that universe? And that was it. That was the mantra. When I went through grad school, I just wanted to figure out how to invent the technology to live in a Star Trek universe. Because Star Trek was ideal. Nobody was fighting against each other. They were in the pursuit of science and discovery, and they had all these awesome toys, right? So as far as immersive analytics is concerned, because I'm a very visual person, and also because all of you are visual people, half of your brains are dedicated to processing visual information. So it's like saying, if I'm not going to use a visual to understand a problem, I'm not going to use half of my brain to think about a problem. So think about that for a moment, right? And so I started being really interested in this idea of using things like virtual reality in this holodeck kind of environment, but for scientific discovery, for sense making, for computer supported collaboration with other people, and with collaboration with artificial intelligence, right? And so I think generally speaking, that term these days is called immersive analytics. You're immersed in data. So my first foray into virtual reality was in the 90s, where in Chicago, they invented the Cave. And inside it, you project 3D computer graphics, you walk around it, and things appear to float in the room with you without having to wear heavy headsets, which was making everybody sick and nauseated, right? And the fun trivia is later on, people said, oh my God, this is the holodeck. And in fact, my advisor who invented it hadn't even watched a lick of Star Trek, The Next Generation, to even know what the holodeck was. And the person who did, the co-director, who's a physicist, who did all the math for all the projections in the cave, he's actually dyslexic, so he can't even see stereoscopic 3D. So it's like a blind person invented stereoscopic 3D for the cave. And later on, I'll show you even how even more important that is. But my first project was to connect a simulation on a Sun Spark computer connected to a supercomputer in Caltech, run the simulation, which connected using this network as a neuron to fire that simulation, and then bring all the data back into the cave to visualize in 3D. And I didn't realize at the time, but this was the first time anyone had connected a VR to a supercomputer and steered it basically in real time. When I was working on my PhD, I hooked up with General Motors, who was building caves in Europe as well as in Michigan. And they wanted a way to evaluate interior designs of their cars. And so my PhD was developing this collaborative infrastructure to allow caves to connect to each other. We had, like everyone else these days, we had avatars with heads, and they were pointing at each other. You know, they looked kind of goofy. But for GM was really valuable because they could talk to the designers in Europe and see the designs and change the designs dynamically. And they would connect it up to Maya, which is their software for doing the design tweaks. I found out about 10 years later when I could actually afford a BMW. BMW gave me a little care package and I put in their disc, and they had a video of the cave and they were designing their cars in it. And then now I also know Porsche also uses VR technologies too, and also Ford and so forth, right? So then, after that, in 2000, I got interested in lots of displays. In other words, these technologies, these display technologies were starting to get cheaper. We're sort of getting away from CRTs, right? The old big CRTs to flat screens. When we thought, well, if we had stereoscopic 3D displays and 2D small displays and 55-inch displays, how might people work collaboratively in that space? And so Office of Naval Research gave me some starting funds to build out this space called the Continuum. And we were doing user studies and developing tools to allow people to navigate, like move a mouse pointer across these displays like it was a continuous, display, right? And what we observed was really interesting. What we found was when people started working on these big displays, and then they were forced to work on a small display, they really felt like they just were taken off drugs, right? They had these reactions like, oh my God, I need my big display back. But also I noticed that when I look on a small display after this experience I was actually going like this, looking at where's the rest of my data? Like it was around the corner or something like that. So it has this weird, strange feeling about this. And then later on, I'll talk about Dylan's work, which will also sort of amplify that people actually, if you give them lots of space to space out their data, they will naturally do it. And we found that the big benefit of this was that people could work in parallel in these spaces to solve problems much more efficiently. And people have verified this using just smart, traditional war rooms using paper, but we've sort of verified it in a digital medium as well. Then in 2004, as part of a project called Optiputer, we were trying to imagine if networking bandwidth was no longer the limit, right? This was the time when the dot-coms were going crazy. How would that transform computing and the way people work? So then we started thinking, well, a giant compute cluster full of hard drives could be considered just one hard drive. A giant compute cluster with lots of processing units could be considered one CPU. A giant computer would be considered one GPU. And then a giant display wall would be considered one single display driven by a cluster. And the network was the backplane. So how do we invent the middleware to drive the pixels fast enough through these 1 gig, 10 gig, 100 gig networks to make all this completely seamless. So you may have noticed a couple of windows when they were moving around, shifting from one screen to another. Each one of these columns was driven by a separate computer on a compute cluster. And so the software is live streaming all the rendering from a remote service and routing all the pixels to the right nodes to give this completely seamless interaction. So this was 2004. Fast forward to 20 years, like today-ish, NVIDIA has a product called Grid, which is doing remote rendering and streaming it to your desktop computers so that you can take advantage of those computing capabilities. So back then, it was considered crazy to do this. It's almost like considered stunt science. They didn't even consider it science back then. They said, you guys are just doing stunts, right? But we learned a lot in this process, and we inspired a whole generation of scientists to actually start embracing new technologies, which otherwise they wouldn't have the capability to actually use for themselves. As those displays got bigger, the borders got smaller like this, then it was starting to become easier to drive larger and larger displays. And instead of using a giant compute cluster, you can just use one PC with a kick-ass graphics card, right? And that's where suddenly everybody were building these systems. But there was no really good software yet. Windows just doesn't work in these kind of spaces. Mac was not in this space either. So when I moved to Hawaii, I basically took what I did in Chicago and cloned it, except gave it a cooler name called the Cyber Canoe, the cyber-enabled collaboration, analysis, navigation, and observation environment. And this came to me when I was at a talk, sitting in a talk about the hokulea at Bishop Museum. And I played with the word canoe and I thought, oh, this is it. This is what we're going to call Hawaii's display walls, Cyber Canoe. So in the immersive space, the projectors that we were using to drive caves were really dim, really low resolution. We could not convince display manufacturers to produce higher resolution projectors and brighter ones. So we started working with a company called Planar to custom design these LCD panels to provide stereoscopic viewing capabilities. We basically put passive polarization layers in each pixel. But because if you're off axis too far, you're going to lose stereo or you're going to get flipped stereo. So we work with them to shift the polarizers for that off axis view. So you get much better off axis viewing for viewers. They manufacture these panels, and then we work with a company called Mechdyne. We licensed the technology to them because it took us every ounce of blood and sweat to make our first prototype. We couldn't replicate it for people. A lot of people, they tend to like to get a copy of the stuff we make. So we work with Mechdyne, we license it, and then they produce these for other people. And so Raytheon was like one of the first locations, actually second location. The first one was Monash University that has a cave 2. And when I moved to Hawaii, I wanted the same for Hawaii. And so we essentially built this system, replicating this using OLED displays. These were all previously LCD displays. These were OLEDs. And when we were done with this, it's here. These displays are actually, maybe I should sign the back. Maybe there's some value to it if I sign the back. But these displays are exactly the displays that drove this. So
we have to thank you. I don't know if anyone realizes besides Dylan.
I don't know if you want more displays.
Thank you, Jason.
Always like more.
Okay.
These are his old ones. That's
I was
why.
just telling Dylan, I'm about to get rid of probably 15 displays in the summer that drives our Hawaii Data Science Institute. And I'm looking for anyone who wants them. They're also LCD, but tiled.
Absolutely.
Okay, we'll talk. So the way I've always been thinking about these advanced displays, right, and also to justify to National Science Foundation for having spent all their money, is that we spend an awful lot of money in data collection, right? We've got telescopes, we've got ocean drilling vessels. We spend a lot of money in computing the clusters. don't we need an exquisite eyepiece for the human to look at all this beautiful data? And so that's how we think of these large display walls, right? So we argue that the quality of the lens determines the quality of your insight, right? And somehow that they believed us. And so, you know, every time we turn these knobs in our microscope, we're actually tweaking the computers, right? So this was a good metaphor for NSF to swallow. So let's figure out how to make software to make these things work. So we started looking at how do people deal with scale and complexity, right? We did this. We took this photograph in our lab. We gave students a task. We threw them a jigsaw puzzle and we just filmed them trying to solve it together on the table. And you can see different teams were doing things in parallel, like they're doing finding regions for edges for the puzzle. Another group was actually clustered all the pieces based on color, right? So this is a completely parallel task. And if you go to...
Only the women are working. Why is that?
That's a very good point. That was many years ago. It's all different now. Hopefully. This is Disney, and you've probably seen these, right? In the storyboarding rooms, right, where they talk through the ideas. This is BMW. This came as part of that video that BMW sent me. They had this thing called the Wall of Inspiration, and they had time across the top of the wall, dates. They had photographs of car designs, fashion, and architecture. And the reason why they wanted that was because a car is always seen in the context of the person, what they're wearing, and their backdrop. And as architecture evolves, as clothing evolves, they wanted to make sure their car was somehow right in that. I don't know, I'm not a designer, you know, in that context. And so that's really struck me as this is a perfect example of something that you could use a large display wall for. So every time they found something in a magazine, when we used to read magazines, you cut out a magazine and they would just tape it onto the wall. This was a great picture of Al Gore. Clearly, he doesn't do any work here, right? Because there's just too much data. And he has 3 30-inch Mac screens because really that's the only way he can manage this, right? And even then, today, if you think about the Mac desktops, we're drowning in our laptops in our data, right? And I'm sure Apple's going to spend a lot of time in their AI thrust to help make us figure that. They'll help figure that out. The history of Sage. This has been funded by National Science Foundation at $1 million a year for 20 years now. So I have to thank NSF a lot for that. Original code base was in C++. And you see it right there, what that looks like. Back then, grid computing was the thing. Facebook had just started. Facebook is richer than me. Sage 2 emerged roughly when I moved to Hawaii. And now systems to drive these display walls were going down from 500,000 to 1 million to 100,000 to 300,000. And then science portals and gateways and cloud computing was starting to become popular. And then 2010, COVID happened. And then when COVID happened, none of us could go back to sit in front of a Sage wall because we couldn't be co-located. And we thought, oh shit, what do we do? And so that was our opportunity. This is my desk during COVID. I bought 2 46-inch TVs because they were like $500 a piece from Best Buy. Put them together, so I have a tile display. These are 4K each, right? And that was what got us thinking about how do we make Sage work from everything from large displays to home TVs to laptops. And now we have a completely hybrid system that works at any scale. And it's open source. I want to show you this video. Virginia Tech. This is Chris North of Virginia Tech. He's the world's foremost researcher who does user studies about sense making in large display environments. They just built their display wall at Virginia Tech. This video is literally 1 day old. So and he's such a great talker. So I thought there's no better way to sell Sage than to have him do it for me.
there's two key features of this new classroom that are novel, unique to any other classroom on campus. The first is this large high-resolution display at the front of the classroom. The other key component is our Sage 3 software, which drives the display and enables students to connect to the display from their laptops and do collaborative interaction. Particularly for a data visualization class, I can display a lot of data and a lot of visualizations. A simple example is, well, hey, now I can display multiple slides instead of just one slide at once. And so now as I'm talking about one slide, the students can still see back and I can still refer back to previous slides in order to make connections. The second key capability is the ability to allow the students to collaborate. And so the students can connect with their laptops to this big display through the Sage 3 software. And they can contribute. They can add information onto the display. They can manipulate things and help organize things. They can do things like brainstorming exercises, design exercises and things like that where the students are contributing.
It's a really big screen, so you can fit more information on it. You can have different images surrounding your PowerPoint showing exactly what you're talking about. So it allows for the option of students being on the board at the same time that the instructor is. And what this can enable is more effective engagement with material. We know that when students actively engage with material, they're more likely to learn. So in other words, it allows teaching to be less of the classic model that we see, which is very much instructor talks, you listen, and more of a collaborative discussion between the instructor and the students.
But I do have to admit that we encounter, not just at UH, but nationwide, because instructors still come up with the podium, do a PowerPoint slide, close it, and walk away. Because for them, sadly, they're not incentivized to think about new ways of teaching, right? But if they do get into this, people who do get into this, they really have a lot of fun. So we're trying hard to try and introduce them to that. So some of the features that I want to highlight in what you can do with Sage is that each one of these things that you see up here, they are parallel screen shares from multiple laptops. So as long as you have bandwidth, you can screen share multiple things. So imagine you've got a situation where you want to bring in a bunch of people and you want to look at all their information simultaneously. You don't have to pass the cable around, say your turn next, your turn next. Get it up there because you can do that completely in parallel. You can make any one of these as big as you want, small as you want, and move them around. You might have seen a bit of this towards the end. So we now have the ability to do essentially Jupyter notebooks inside Sage where every one of these cells are spatialized. So every one of these is where students could write code collaboratively. And then when you hit the run button, you can run through your notebook to do your data science. And so Chris North did a study of users of Jupyter notebooks, and they had them take their notebook cells and ask them, how would you lay this out? Most of them tend to lay things out sort of spatially. And so they actually all want this spatial layout, but Jupyter doesn't do it because it's convenient to put everything in a browser. And so that's kind of sad, right? Because the browser came out how long ago? And we're stuck in browser land still. And so there's room for innovation, especially as these TVs, these high-resolution displays, are getting so freaking cheap. So that's in Sage now, and Chris continues to lead this effort to design the next generation of computational notebooks. This one is more about no-code dashboards. So more and more, you're probably hearing companies like, what's the big one, the Viz company? Tableau. Tableau now is working in things like no-code dashboards because, like everybody else, when they stop talking to computer scientists, they realize the rest of the world doesn't want to code to do their science. I remember 10 years ago when I started teaching at UH, I had to teach intro computer science, which was teaching Java. And my first thing I said to the students, and I shouldn't have said this, but I guess I should have, I said, I'm sorry to have to force you to teach Java. It's only because we computer scientists aren't smart enough to understand English to automatically write the code for you. And now it's becoming really, really true, right? That you can actually do that. So the stuff that we did in the science space also caught interest in the media space. Disney and NTT invited us to do a show and tell at Disney Studio to all their executives about what would collaborative film production be like in the future. So we basically rolled in a tile display wall with sage and so forth, and we gave a demonstration. And as a result of that, we won the California Scenic Innovation Award for our work. And it was exciting because we got to work with, what's his name, Kaczynski, who did Tron 2. And we got all the early footage and said, oh, this is what Tron's going to look like. So nowadays, many of you are probably familiar with cool shows like The Mandalorian and Star Wars. Of course, I'm a huge Star Wars fan as well. I think about a decade ago, I saw ILM was starting to use the cave as well. I thought, oh, cool, they're using caves. And this is called the Volume, Disney's Volume. And what it is essentially a giant cylinder, LED cylinder, where they project computer graphics of the background scenes, all computer-generated scenes. And then when they move the camera around the character, the scene adjusts to create this, to complete that illusion. Well, all the mathematics, all to compute all those views are exactly the same mathematics that drives the cave and the cyber canoe that we developed. And so it's finally sort of paying off, right? The research that we did to train the students to learn this stuff, now they can actually have a job, right? But that's the nature of research, right? NSF, they don't like to fund us to do research that competes with industry, right? Because industry is responding to immediate needs, right? So they want scientists to think 20 years ahead because they know it takes 20 years for technology, for basic research to actually become the Walkmans or the lasers, right? If you think about the microwave, lasers, it took about 20 years, or the chip, it took about 20 years to go from prototype, which is usually like this big, to down to this big that fits inside a Walkman or a CD player, right? So, but there is interest in trying to squeeze, shorten that time frame so we can, because a lot of other countries are also trying to do this, right? To speed up the rate of research innovation and then and transition it to industry. And that's what the new TIPS program is about. You guys familiar with the TIPS program, NSF? Yeah. This is a new program. In 30 years of NSF, they've never had a new program, and this was their latest program. We started working with folks like at Sharp, who was also starting to be interested in large display walls back then. The chairman of Sharp said 10 years time, entire walls would be screens. I gave a talk in front of an audience, and Samsung was in the audience, and I was talking about the large displays. Samsung came up to me and said, do you really think people are going to have big screens at home and things like that? It's like, who makes most of the big screens at home these days? Samsung and LG, right? Texas Advanced Computing Center. Now, this started becoming a pissing match now between universities. I've got a 100 megapixel wall, so I've got to make a 200 megapixel wall, and then oil company money gets into the mix, and now I have a 300 megapixel wall, so it just never stops. But they were all, and this is UC San Diego's, they basically fill their entire room with display walls, but they are all running Sage, basically. Monsanto, I know some people don't like Monsanto. So they had collaboration issues between India and their home base, right, in the United States, and they were trying to find a bridge between them, so we work with them to help them get Sage up and running in their space and develop tools. This was with NASA. This was Endurance, basically this probe that got placed in Antarctic under the ocean with the plan that this would be the prototype of a probe that would end up in Mars, right? And so in this side of the cave, they had 2D products, and then on the right side, it was stereoscopic 3D. So they could immerse themselves in the data set, see the disconnect between the scanned data points, and then look at this from a 2D layout. And then, you know, all the furniture is rollable, so you can move things around to create this dynamic space. And then people are using this space for nursing too, like nursing classes and also research. It just became really popular to sort of hang out in that space. And then we got really tired. We couldn't support all these people anymore. We had like about 4,000 display systems out there. And so this company came to us from Brazil that wanted to build operation centers for police and power plants. And so they licensed a copy of Sage 2. And then they started building them. And then they got big, and then they bought a second license for Europe and the US. And so now they're taking care of that. And they have a version of Sage, which is now called Multiviz. And they will deal with it. I still get a small royalty check now and then. So why does this work, right, from a scientific standpoint? So there are a bunch of researchers who studied this. Chris North was one of them. And Chris North has been great because it was the easiest way to justify to National Science Foundation why this is good and why they should give us money to build better things. He had done the user studies. And so all these other researchers, not just Chris, had done user studies and basically found all these benefits with working large display walls. You can see detail and context at the same time because you have that resolution. You can use the most natural user interface for seeing detail and context, which is walking up to something and stepping back. And in the process, you can up your step count for the day. A large display helps you externalize your working memory. If you've got a bunch of smart people, they're probably thinking 1,000 smart things. Get them to type it and throw it on the wall, right? Because we can only hold about 7 things at a time. Get it on the wall, externalize your working memory. I already mentioned this, increases parallel processing. Somebody can work on that side of the wall. Somebody else can work on another side of the wall. In Chicago, they expanded their room. So there's one big wall and the second big wall so that you can have parallel work. They found that as you increase data sizes, having a larger display actually help people understand data better. Ultimately, people feel more confident that after they leave a room, having seen everything, that they haven't missed any. So they feel more confident about their decisions. And then I think for me, most importantly, is you start to see the higher level patterns forming, right, between all the data sets. Right? Before, if you're looking at a small screen, you're just staring down one small data set. But if you can see everything like a giant jigsaw puzzle, that's when the picture starts to form, right? And somebody, sure enough, did a study. Actually, that was my postdoc. Did a study on that. In the interest of time, maybe I'll skip this. We actually, during COVID, started comparing what it's like to work in front of Sage versus Zoom. So this is traditional sitting in a room, use a PowerPoint projector. This is in Zoom, and this is with Sage, but Sage 2. So you notice these two are very similar, right? So in that regards, Zoom is kind of doing its job. It's doing a good PowerPoint show, right, for meetings. These are all the metrics, by the way. Like, I maintain focus on the meeting. I contribute content to the meeting. Most participants contribute content to the meeting. Most participants contribute content at appropriate times. So all these different metrics. And we found that for Sage, everything was leaning more towards strong agreement that the meeting was actually more engaging and productive. Now, that said, we do get users who will just have a giant display wall and put one big projection slide like what I'm doing here, and we try to warn them that if you do this, you've wasted a boatload of money for nothing. So don't do that, or else don't even buy it. Just get yourself a projector, it's cheaper, right? If you had, I didn't know you had guest Wi-Fi. I could have done my whole entire presentation in Sage. But anyway. Because honestly, the reason I give that advice is a lot of people come to our lab and we give them this demo and they get really excited with our tech. And I hate it when they go home, they spend a lot of money and they don't use it and it gets mothballed because it looks bad on us, right? And so we really actively engage in a lot of training to get people to really we've noticed that it's not obvious to most people how they can use this tech in a variety of, there are sort of different recipes that you can use to be more productive in that space. Just like when you buy an Instapot, I bought an Instapot a couple of years ago, it comes with a recipe book. They figured it out. So we need this too, basically. So this is Dylan's work. Now we can make fun of Dylan. This was his PhD. About a year before that, I took a Quest headset home, and I hacked a little prototype to bring in a Sage wall into my VR headset. I was sitting in my home, my 10-foot by 10-foot room, and I was looking at a 15-foot wall. And then I brought a second 15-foot wall next to me, and that's where I realized, oh shit, we're going to be out of business, right? Because this is really compelling that I can actually have a 15-foot wall in my house now, right? The technology is there, right? But the comfort issues are still a big problem, and as Apple is starting to discover more and more too, right? So, yeah. So in Dylan's PhD, and so this was the idea, like, you know, Iron Man can carry his Iron Man suit anywhere in a suitcase. Can we bring a Sage display wall in a suitcase? And that's the VR headset. So Dylan did a prototype. He did some user studies of people working as if they're in front of a display wall, putting up documents and observing how do they use the space, how much space do they use. And what he was able to figure out was they are capable of doing all the same tasks in front of a large display wall, physical wall, in VR. They use twice as much virtual space as physical space. Basically, people will use space if you give them space. And the nice thing about a virtual space is that it's infinite. They can have a display wall bigger than anything they can afford. Right? And it just goes back to that analogy where I said, remember when you started with the big wall and you try to go back to the small laptop, it's kind of like really claustrophobic, right? People naturally would like to space things out. I remember recently when I bought my house, I mean, oh my God, this kitchen is huge. I've never in my entire life had so much stuff I could even put in this, and now it's full with crap, right? People will use space if you give them space. Anyway, okay. So far I've talked about virtual immersion, right? Nuri Kirschenbaum, one of my postdocs, I hired her on as a grad student at first, and then she became a postdoc. She was into tangible computing, you know, physical objects, and putting computing in them. And I wasn't sure what to do with them because, you know, a lot of what she did was for children's toys, right? And I thought, well, I'm a scientist. I try to make science better. How do I use this? Then one day, the State Energy Office came, and they wanted to look at how Hawaii was going to go to 100% renewable by 2045. Just like the Alawai project, HECO gave the legislators and the general public 4 binders, 1,000 pages each. Okay? And the State Energy Office said, can you help us visualize those binders so it's more understandable to the general public? So this was the birth of using physical objects to display map layers. And then we work with you guys and it's excellent. We don't quite understand this yet, so we want to study it. But for some reason, when people see that physical thing, it's like light bulb really sets off. And then they're more interested in actually looking at the data. And I think part of it is because people like things that are physical, and they're jaded by iPads. And almost things that are retro are almost interesting to them because they've never seen at least newer generations of kids, right? Just like new kids like these old Nike shoes now, which Nike gets to resell for $150. Wow, that's brilliant. Don't invent a new shoe, just resell an old one. But so now we're as part of the Change Hawaii project, we're streamlining this. Now we have a kit that other people can just go buy from from Best Buy or from Amazon, and then they can piece together this real fast, and then Nareed's working on the software to make it easy to just put their own data layers. The 3D printing, the large scale 3D printing is a challenge for most people. We have a giant printer now. We invest in a giant printer so we could do that. And the audio is coming from this. Here's companies who can do the 3D printing for us and for others. So that way we'll just say, go to them and the model and so it's again, because we've gotten so popular, we couldn't handle it anymore. Let me talk real briefly about human AI interaction. As I said, I want to live in the Star Trek universe. I want to talk to computers. The first thing I did when I got Alexa was change it from Alexa to computer. That's always a big mistake when you watch Star Trek, because they say computer a lot, and that always triggers Alexa. And then I have 10 rolls of toilet paper ordered inadvertently, right? So nowadays, you all heard that AI is big and large language models are big, right? And it seems like everywhere you turn, people are stuffing large language models into everything. So it's becoming almost faddish, right? Back in 2008, I started working in the area of natural language to visualization, where basically you tell a computer what you want to see, and the computer figures out what's the right chart. And what I mean by that is not just say, computer, make me a bar chart or a pie chart. That's easy. We want the computer to say, computer, what's the correlation between COVID risk and blah, blah, blah. And the computer has to figure out, oh, based on your query, we think this is the best chart to actually display what you need to get done. We prototyped it. 6 months later, Siri came out. I thought we are on the right track. Siri is doing voice. Then Google Voice came out. And we thought, excellent, we're definitely on the right track with this stuff, right? We sent a grant proposal to NSF. We sent it 3 freaking times. They rejected us every single time. The reviewer said, we don't think people will ever want to talk to computers. Because the cognitive load of talking to computers is just too high. And they cited Ben Schneiderman. And some of you know Ben Schneiderman was a huge, big person, legendary person in human-computer interaction, right? But the problem is Ben did his research using old tech where the computing wasn't powerful enough to do the natural language translation, right? So after 3 tries, finally NSF gave us a squirt of money because they still thought we couldn't really do it. And 2 years ago, we gave a demo of this system, and UIC, who was one of our partners, gave a demo of the system. People came up to them and said, is this real? Can you really do this? They were still in disbelief that we had advanced far enough to be able to do this. So I'll just give you a quick show of this video here. This is RJ. So RJ's just talking to him. He just said, where's COVID risk most prevalent? And it's produced a chart. And so every time a new chart comes out, it provides a number of possible suggestions. And then you can drag the ones you care about, right? And just to add a little bit of embodiment, we just put a little cute icon. I did that one. I designed that. See, I don't get to code anymore. I just make cute icons. So what was special from 2022 versus 2008, in 2022, RJ, who was just a new grad student, could basically replicate what my Ph.D. student did over a course of 2 years in 1 semester, because the technology had gotten there, the neural nets were there to be able to do this. So to add on top of this, because this isn't hard enough, what we decided was we were going to make it an always listening system. So you imagine you're in a collaboration, you're all talking, this AI is one of your collaborators, one of your friends now, listening in on this conversation. And we want this AI to be spontaneous in going, okay, I heard that. Okay, I'm going to give you one of these. Instead of saying, Alexa, go do this, you let the AI be a first-class citizen and start putting stuff up there. And then when a user actually says, make me a chart of blah, 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 normally with Alexa, you have to be very explicit. Alexa, give me exactly this. In this system, because it's listened to all the context, all you have to do is say, oh, let's see a chart of that. It knows what the previous context is. And then when the user kind of slips up, or sometimes the user say, well, I think we could look at COVID risk, and he doesn't even finish his sentence. Our AI has picked it up and filled in the blanks like autocomplete, just like what large language models today, and it'll put the chart right on the screen. Or somebody will slip and say an attribute that doesn't exist, and it will correct and go, oh, I think you mean this, and just throw it in there, right? So that's the awesome promise that these large language models have for data analysis, right? It's some of you probably use Copilot, right, to write code, right? My software engineer who developed Sage, he's like got Copilot in his bed, right? A lot of the code that he writes is through parallel coding with Copilot. So Microsoft is going to make a lot of money. And then we're working now to embed more and more of these large language model capabilities into Sage, where people can just make dashboards without coding, talk to it as if it were one member of the team. In the future, imagine different companies will have their own little smart AI hanging around the space. I think figuring out how AI is going to be an interactive presence in everything, we haven't figured out yet, right? Our cheap solution is the chat box, right? It's as old as the browser, older than the browser, right? So there's a lot of opportunities, right? In robotics, in smart cameras that you can talk to, and so forth. Okay. I'll switch over a little bit and I'll end. This is the work I've been doing with Chris Leigh, right? Because I knew he was coming, so I had to do a slide. No, just kidding. So Chris has been a really good collaborator. He built this awesome facility at UH West Oahu. If you haven't seen it, it's a state-of-the-art space for teaching digital media. The students here are really fortunate to have these capabilities. I've brought in I've shown this to folks at WETA when I was visiting them in New Zealand, and they were blown away that kids have access to this. Actually, the person in charge of the school right next to WETA said, "Can I come and work here?" This is the space that Chris gave me. It was a 30 by 30 foot space, and I had some extra budget, and I was thinking of doing projection mapping, because that seemed to be things that were interesting to people. Starting to become interesting to me. This was just before COVID, so like the Van Gogh thing, the Beyond Van Gogh exhibit came out. So projection mapping was really in. I was just in Vegas last year, and my God, it's like projection mapping is gone hog wild. Now they have the sphere, right? And so Chris said, hey, have you been to Team Lab Borderless? And I said, no, I haven't. They're into this projection mapping thing. I said, well, funny you should say that. I was trying to decide whether I was going to dabble in this space. And so I threw in some money to build this. And then Chris gives me some money every year. So I always take that money and just, okay, we're going to add more projectors now. So we now fully have projectors on the walls as well as the floor. So we're sort of piecemealing this with El Cheapo projectors. Like these are $1,000 PowerPoint projectors just as a prototype. And then the students learn what are the media boxes that have to be interconnected, what's the right software. So I don't know, if you guys have money, hey, give us money to build a really super projector. But anyway, this is Team Lab Borderless. This is what happens when you have Epson donating to the space. It's just absolutely gorgeous. If you haven't been there, it's in Odaiba in Tokyo, and then I think there's one in San Francisco, right? But you don't have to, well, yeah, you should go there. It's really cool. They do a great job. some of this stuff here are some of the students' projects from last semester. I think you just missed the Star Wars one. I gave him an A because it was Star Wars. But I was in Vegas a year ago and I went to the Illuminarium, which is also really, and Chris was there too. And then because of building this space in West Oahu and so many people coming to see it, like the aquarium, they saw it and said, oh, we're renovating. Would you like to do this for us? So they carved out a small space for us right in front of that giant shark tank. So we've got all the code written and everything, and so they're renovating the space now, and they're going to put projectors up. And that's it. So thank you very much.
Questions?
Excellent. Oh yeah.
How would you approach a group of people that were maybe visually impaired but wanted to use this type of technology?
That's a really good question. So that's a space that there hasn't been as much innovation as I'd like. When I was a grad student, I had a blind roommate. And I was really curious about that question. And we were looking at Braille displays. They had tiny little pins that you could use. The chief challenge is throughput, right? There's very little data throughput through fingertips. But your audio channel is really good, right? So you would definitely leverage a lot of that. Maybe spatialization, a lot of spatialization. Yeah, I don't have a good answer for that, yeah. But thank you for asking. That's good pointing it out. There are going to be generations, my mother has macular degeneration, right? I'm genetically inclined too, so yeah, so that's going to be important. And also as we get older too, we're going to have half of us, if we live to 80s, we're going to have dementia, right? And so this is where we don't have enough babies now to take care of us. So like Japan, who's realized this, they're building robots. It's almost like a sad future, dystopian future, but they're investing a lot of that in AI so that they have things that can still take care of us. Yeah, so I don't know. Sorry, I went on a dark note, but you're absolutely right. Thinking about those social issues. Yeah.
Other questions?
Yeah.
What are you excited about with large language models?
Oh, yeah.
I you said, but like,
yeah.
where is it going to settle? Or what are you excited about?
I'm excited in so many unexpected ways I've been able to use it. And every time I don't think of ever asking a computer to do this. Now I have to force myself, let's try it, just to see what it would do. So for example, after a research meeting, right, we've got notes about all our ideas, right? And usually we're done because we're the smart ones, we know everything. So now we'll feed it into ChatGPT and say, what have we not thought about, right? And it will invariably pull something out and we go, oh yeah, I didn't think of that. So let's say I'm not a person who's an expert in publicity and I'm trying to promote Sage. I'll ask ChatGPT, what could be a promotion strategy I could use for an open source software about collaboration and so forth? Type it in, and it would actually bullet out a strategy. Because I do know something about how to do publicity. I look at those bullets and go, yes, oh fuck, yes, oh my God, this is really good, right? One time there was a problem in Unity I could not figure out how to solve, even with my expertise and also watching videos. So I typed into ChatGPT, it came up with a solution. I followed it, oh wow, it figured it out. It wasn't in any of the user manuals. In any of the blogs I've seen, it managed to figure out a viable solution. So I've been shocked about how good it is. But I'm also cautious because there are cases where it makes mistakes. Like in the visualization work that we've been doing, trying to test how good large language models are for the visualization stuff, it is still making mistakes. And so we're trying to figure out how to correct for those. Yeah, so yeah, it's for a lot of domain scientists, it's like opened up a lot of things. Like folks in genetics, right? They thought, oh my God, these Gattacas, right? They're just characters in a string. AI is really good in finding patterns in this. And so the whole biology industry is like hog wild in this. geosciences as well. At the American Geophysical Union conference, they're like, so many, the whole discussion was, we're doing this with AI, we're doing that with AI, we're doing this with AI. So for domain scientists, it's a great time to be alive, because finally all those hard problems you couldn't dream of solving, you can finally solve. And so for computer scientists, some of my students who used to work in AI were a little disheartened. We had a bunch of students who basically, oh crap, I just lost my thesis, right? But the ones who didn't lose their theses were people who were studying things like, how do humans interact with AI? What are ways to design human-computer interaction capabilities? Like, for example, the always listening stuff, right? We're now starting to look back at pragmatics, right? Which is this area of linguistics, right? That looks at how people understand each other through context and what they say. We could never operationalize that in the past because we never had the compute power to operationalize pragmatics. Now we can do systematic studies of pragmatics and actually make them real and actually test against what the psychologists and sociologists have observed, right? So it really opens up opportunities to make better user interfaces and also for fundamentally moving the needle forward in social sciences and psychology and social psychology. Yeah, so I'm excited.
I'm terrified too.
I know that kill human stuff. Yeah, that's terrifying too. Yeah. Yeah, there are some negative stuff that could happen. Yeah, and will.
Other questions? All right. Well, thank you. This has been really awesome.
Well, thank you all.